I'm Lucas, and I contributed to the MRT tab of our application. The MRT tab starts off with an MRT map that was constructed using Leaflet. This will be used alongside the data table that will be mentioned next to show users on the MRT map which stations are affected by train faults when the user interacts with the data table. Below the leaflet map is the data table that was created from extracting and cleaning relevant data from the official Twitter accounts of SBS and SMRT. Relevant data includes which line the train fault occurred on, what kind of delay it is, which includes breakdowns, delays, or resumption of service, the start and end stations affected by the train fault, and the date and time which the train fault occurred on. Because we extracted the data from the Twitter accounts, there were many irrelevant tweets and replicates due to the repeated tweets on the same train fault every 15 minutes. As such, I was also in charge of manually going through the extracted data and removing irrelevant tweets as well as replicates. This also involves correcting errors in the tweets, such as the stations in the tweets, as they can vary. For example, Ang Mo Kio can sometimes be written as AMK or Ang Mo Kio without space and caps. Clicking on an individual fault on the table will show on the MRT map all the MRT stations that are affected by the train fault by placing an icon on the station itself. This icon will be representative of what kind of train fault it is, so that users can tell at a glance which station is affected by the train fault and what kind of train fault it is. For this feature to work, two key points are necessary. Firstly, there must be a list of stations for each line in order, so that our code can label all affected stations in between the start and end station, since our data only includes those two stations. Secondly, we must have all the coordinates of the stations on the leaflet map, so that the icons that mark the station will appear at the correct longitudes and latitudes on the leaflet map. To solve these two issues, I first created a CSV file and listed all the MRT stations in order. For lines that are split at certain points, such as the east-west line at Tanah Merah and the circle line at Promenade, two CSV files will be created, and the second file will be labeled as a split file. As can be seen from this circle line example, the files are identical with the only difference being the split stations, with the original file which is shown now, starting off from Dhoby Ghaut, Bras Basah, Esplanade, then Promenade, and the split line which starts from Marina Bay, Bayfront, and rejoins the original line at Promenade. Following this, I manually obtained the longitude and latitude of each individual station, using a code that shows the coordinates of each station when I clicked on it on the leaflet map. After obtaining all the coordinates, I then included it in the relevant CSV files. The result is a completed list of all the 7 combinations of lines and splits in CSV format, which includes the circle line split, the east-west line split, the downtown line, which also includes all the new stations that have recently been released, the north-south line, and the northeast line. There are also 2 CSV files which are separated by whether it is owned by SBS and SMRT. This CSV file shows all the stations that are under SMRT, and this file shows all the stations under SBS. This is necessary due to the fact that our data table is created using data from the official SBS and SMRT Twitter accounts, so 2 CSV files are required for the code to correctly reference the MRT stations. Lastly, the code is also programmed such that it takes into consideration the order of the stations. The to and from stations are not always in one direction, as shown in this data table. One breakdown can start from Queenstown and end at City Hall, and the other can occur vice versa, from City Hall to Queenstown. As such, the code is created in such a way that it will correctly function on both cases. Below this data table, there are 2 graphs created using DYgraph. The first graph is a plot of the MRT breakdown timeline, and the second is a plot of the MRT delay timeline. The x-axis of both graphs are the durations of breakdowns or delays, and the y-axis is the time period. The function of this graph is to show which periods of time has the most hours of breakdown, and these hours are also color-coded by the lines which the fault occurs on. Lastly, there's a slider at the bottom of the graph so that the user can adjust the graph to focus on a specific time period if they so desire. Apart from the MRT functions, I am also the overall in charge of the recording of the minutes of our meeting, as well as the software requirements specification document in charge. This involves vetting the overall document and everyone's contribution to ensure that the overall flow of the document is not awkward, due to many people working on the same document. Thank you.